This illustration deals with the definition of fault current, NEC Article 100. Purpose of change was that this new definition was added to address fault current. This new definition defines fault current as the current delivered at a point on the system during a short circuit condition. This new definition is based upon the results of an NEC correlating committee task group that reviewed the use of the term fault current, short circuit current, and qualifies just exactly what a fault current is. And notice maximum was deleted in the illustration because this section, the utilities just couldn't give you the exact fault current due to transformer taps being made on their lines, big motors starting, large motors, high efficiency motors starting with higher inrush current. So they just kind of gave you under normal operating conditions. Now, first of all, to really get a real handle on this, you would review 250.4A5, and it explains that to have to clear a fault, you had to have a low impedance path, and the earth could not be used as a sole means to clear a fault. So if you ground the transformer, you have to ground at your first disconnecting means. Sometimes utilities will even have you ground at the meter too. But now that's based upon a utility requirement, not the NEC. So thirdly, look at the illustration. Well, it includes the conductors from the main panel over to the electrical equipment. And the title head, is available short circuit current. Now, the low impedance path there is based upon table 250.122. Like, for example, if you had a 200 amp breaker, then you would need a number 4 equipment ground pulled in there if it wasn't metal conduit and so forth, or you wanted redundant grounding, however you wanted to do it. Notice table 250.122 would size that. But now, looking at the transformer to the left, the available fault current at the transformer, for example, if you had a transformer that would have an output of 1,000 usable amps over to the service equipment, then and say you had a 2% impedance. Divide 2% into 1,000, you'd have 50,000 amps available at those terminals of the transformer. That'd be your available short circuit current. The only thing really that would lower that would be the size of the conductors routed from the transformer to the circuit breaker that's in the panel board. And notice that would have an available short circuit current there that would be less than what would be at the transformer based upon the impedance of the conductors. Now, next, if you reviewed the tables, which I'll do shortly, but second, I would like to look at the low voltage output side. That could be, say, 480, 277, 120, 208, 240, 120, three-phase, four-wire, or it could just be a 120, 240 single-phase. But notice that's the low voltage side, what we call the output side. The input side would be the top side of the transformer, which says AC or DC source. Now, next I would like to view the notes, and note 1 kind of explains what really took place here when you review the notes in detail. A short circuit can occur during abnormal conditions such as a fault between conductors or a ground fault anywhere on the electrical system. Now, usually we call it a short circuit between the conductors, and we call it a ground fault where metal of some sort is involved, where the ungrounded conductor would touch it, weld to it in some manner. And note number 2, it talks about the definitions. Look at the definitions of fault current, short circuit current. Look at the definition of available short circuit current and apply those. Now, a short circuit, you're going to have to go through a EEE dictionary to obtain it. Note 3, the definition of general conditions has been added in Article 100 in the 2020 NEC so that we know, viewing the electrical equipment on the right-hand side of the illustration, notice we have the information, fault current occurred and panel due to short circuit condition. Now, the fault would develop there. Then the equipment ground would carry it back to the grounded bar, and about 10% of it would flow in the earth, and about 90% would flow over the grounded conductor back to the transformer, return on the leg that shorted out, and clear that particular circuit that's supplying that electrical equipment.